Of course, the tenant's body or clothing cannot contain any backdrop color, or else that will key out as well. At this point, many people would ask, how does this differ from traditional chroma keying? Well, the difference between chroma keying and a virtual studio system is simply the transition and camera movement, which is something that you cannot achieve with traditional chroma keying. But we'll talk about that later. Now, after we have obtained a clean tenant signal, the next thing to do is to integrate it into a virtual system. Virtual studio systems can be categorized into different types: the 3D tracking system, the 3D trackless system, and 2D trackless system. 3D tracking systems are capable of receiving pan, tilt, and zoom positions of the camera, as well as the tracking or dolly positions. The studio space calculated by the virtual studio system is integrated into the actual real-time dynamic 3D scene. And this type of system is usually used by professional news TV stations or weather broadcasters. The system cost alone is $30,000 at a minimum, depending on the number of cameras used. This system must be operated using multiple advanced workstations, and the operators must be highly experienced professionals, specifically trained to operate 3D studios. So what is a 3D trackless system? Compared to the tracking system, the trackless system uses an immobile camera, fixed on a particular position, aperture and shutter. Camera movements and transitions are calculated by the computerized virtual studio system. Because it is an all 3D environment, this system requires multiple powerful workstations again. The budget of the overall system can be millions of dollars, but this system only needs a few operators and 3D background designers to run. Thus, compared to the 3D tracking system, trackless systems are much more user-friendly. Finally, the 2D trackless virtual studio system, such as the Data Video TVS 1000. The biggest difference between 2D and 3D systems is that 3D systems allow the camera to track movement, and the studio view and angle changes with that movement. But 2D environments are static. In the 2D system, the camera is immobile, but it can perform lens movement via pan, tilt and zoom to enrich the visual effect. The only drawback is that this 2D system does not allow background rotation and perspective. Hence, this is where a virtual background comes into play. The virtual background can be a 3D background, it can be a 2D picture, or even a landscape photo taken by your mobile phone. At first glance, 2D systems may have a lot of limitations, but more than 70% of programming uses PDZ cameras. For example, news reporting, finance programs, corporate television, education channels, etc. It ensures that the main focus is on the host and their interaction with the guest. Also, the 2D system is an easy tool to operate, with little training required. Only one person is enough to handle all operations and to create an effect similar to that of the advanced virtual studio systems. The entry-level machine costs a few $1,000s only, thus providing beginners with a good tool to realize their vision. The Data Video TVS 1000 is an easy to operate machine that provides high quality work at a low cost. In later chapters, we will show you how powerful the TVS 1000 actually is. So what are you waiting for? Join us and start using the Data Video TVS 1000 now. Hi everyone! In this chapter, we will briefly introduce you to the main functions of the TVS 1000 and various areas of the interface, and then show you how the system works. Before we start using TVS 1000, connect the monitors, the keyboard, the mouse, the audio mixer and the RMC220 controller to the TVS 1000, and then plug in the power cord. Press the power button and wait for about 40 seconds for the system to complete its boot up process. After then, you will then be able to start using the TVS 1000. After seeing the main screen, or the startup screen as we call it, you will be able to see all of the function categories. The categories are Project Management, Still Text Editor, Virtual Set Maker, the Virtual Set Shop, and the Shutdown button. This chapter will discuss project management, and we will leave the rest of the sections to later chapters. First of all, let's move the mouse cursor over the Production Live pane and on the Startup page, and a drop-down menu will appear. You can either choose to open a new file or an existing file. Before opening a new file, please make sure that the selected video format is what you want and confirm that the connected camera supports the selected resolution. After the configuration is confirmed, click your mouse to open a new file. The user interface will then appear after that. The user interface can be divided into 4 major sections. The first section is the upper third of the UI, which contains the preview screens of all materials, such as the camera, the media, the pictures, the text, and the 4 virtual background views, as well as the preview and program out screens. The second section in the lower left-hand corner of the UI contains 4 mix and effects layers, ME1 to ME4. We can configure 3 preset PTZ faces for each media and effect layer, and thus this is equivalent of 12 virtual camera positions. Click on the autoplay button on the right to enable the autoplay, and you will see smooth movement between faces. If disabled, it will only use the cut transition effect. The bottom rows A and B allow the user to place the talent on the corresponding virtual background and select the material to be displayed on the plasma TV. The above mentioned features form the second section. The third section in the bottom right hand corner is called Media Library Management, where users can define the materials for Media 1 and 2, Stills 1 and 2, and Text 1 and 2. We can also configure audio mixer and chroma key settings in this section. Please note that the chroma key settings only apply to the camera source and not to the rest of the media files. After materials, virtual background, and camera faces are all set, the last part will be to put them together by using the virtual switcher. Just like any general switcher, there are 2 rows for switching control: Preview and Program Out. On the right of the virtual switcher, there are DSK keys for the user to define their own downstream key or overlay. DSK sources can be camera,